Alright guys, today we're going to be kind of reviewing what linear regressions are, or trend lines that are linear, and we're going to do that with the do now. So go ahead and pause the video and give this a shot. Again, try your best. Again, please do pause the video and try it. If you get it wrong, oh well, but do what you think you got to do. Get an answer for these four questions, and then watch the rest of the video to try to figure out what you did wrong, if you did it wrong, and if you did it right, great, good for you. Okay. So go ahead and pause the video and do that now. All right. So here's the do now. It says what is a function that represents the line? I can't talk. What is the function that represents the line of best fit? That is our trend line. So we're looking for a y equals or an f of x equals. The way we're going to do that is using our calculator. So I'm going to go ahead and get you started with that, and then I'm going to speed up the video to type all this data in. So first thing you should do is reset your calculator. And then we're going to go type these two columns into our list. I'm going to call the years since 1945 as my x values and the seconds as my y values. So go to list. I'm going to be typing my x values into list 1 and my y values into list 2. So this is where I'm going to speed up the video, and I'll get you started, but I'm going to speed it up and then you guys can follow along hopefully. So I got 0, and then I've got 9, 9, and also the y values going into list 2, 245.4, 239.4, Alright, don't forget to go back and check and make sure that each of these are lined up correctly. They have to be lined up, so for instance, 0 must be lined up with 245.4. You should check them all. 17 should be lined up with 234.4. 30 should be lined up with 231. 40 should be lined up with 226.3. All right. There shouldn't be any extra data on either of these columns. Once that's done, we can just go straight to the linear regression function in the stats. So second list, go over to calc. That was again I'll do that one more time. We go second, the list button, and then we got to go over to calc, and we're going to go down to linear regression because we want the straight line equation to our data. We're going to click on that, and if we wanted to, we could store it into our calculator so we could actually see what the line looks like by doing second apps, which takes us to our vars, variables, go down to option 2, y variables, and then store it in y1. Alright, so this tells me the equation, and I'm going to show you guys something with this as well. So we have y equals ax plus b, where a is negative 0.43, that's going to be x, plus b, that's plus 242.86. That would be an equation that represents this trend line. Now the next question says, what is the correlation coefficient? Well, it would be the R value that would be displaying on this screen, but I forgot to do something, and that was to turn diagnostics on. So let's run through that really quick. You got to quit out of this and clear it out. So we got to go into catalog to turn that off. So second, then program, go into catalog, and we got to scroll down to diagnostic on. So if you couldn't find this R value, trying to figure out why it wasn't there, it's because you haven't done diagnostic on, and then you have to hit enter one more time so that it says done. So let's go back to linear regression, second, stats, over to calc, down to linear regression, and do it one more time here. Now my R values are showing. The correlation coefficient for this data is R equals negative 0.9. I'm just going to round to the hundreds place, 97. Negative 0.97. And that makes sense because we have a negative correlation here. And our trend line fits our data really well. All those points are really close to it. So we're almost a perfect relationship, but not quite. All right, number 3 here says, what is the time after 5 years? Well, this is the time in seconds is our y-axis, and after so many years, so after 5 years, we could make a prediction here and just go up to 5 and say, well, it's going to be somewhere around here. This is 248, this is 240, that's probably, what, 244, so this is going to be about 242. That would be a prediction and an estimate. We can actually use our equation to see if it's going to be around 242 by saying y equals negative 0.43, x is 5 in this case, plus 242.86. And that's not too hard to type into our calculators, so let's do that really quick. Negative 0.43 times 5 plus 242.86. Yeah, 240.71. 0.71, this would be seconds here. And so basically what this is saying, these are 1 mile records, by the way, being ran. What it's saying is that 5 years after 1945, that's 1950, the world record, the 1 mile world record was probably around 240 seconds. Again, I say probably because it's a prediction. So what would the time be at 43 years after? Well, it's kind of hard to see. It looks like it's going to be right at 224 from our graph. That's an estimate. Let's go and get a little bit more accurate using our equation. Y equals negative 0.43 times, this time 43 years, 43, plus 242.86. And let's see what that gives us. So this time I'm plugging in 43 as my x value for 43 years after 1945. And it says that it's going to be about 224.37 seconds. It's a pretty quick mile. So we could use this to predict. Now, obviously, if I kept on predicting like 100 years down the road, to 2045, that wouldn't be as accurate. Eventually, we're going to get into negative seconds, and that doesn't make sense at all. So keep in mind that this is only accurate around where our scatter plot is, and so the 2 points that we've looked at are interpolating and extrapolating. Okay, like this first one, 5 years. 5 years was within our data, so that was interpolating. And our other point was outside our data right here at 43 years. That was extrapolating. So hopefully you guys can interpolate and extrapolate using an equation to a trend line. Well, let's get on to today's lesson. Today's lesson is all about comparing the linear to an exponential model. So this table shows the number of bacteria in a culture at the start of each hour as it is being studied, using a graphing calculator to make a scatter plot for the data. Okay, that's what we need to do. Is it a linear or is it going to be an exponential model going to be more suitable? Now, y'all just came out of the lesson for linear and exponential. This is curvy. It ain't a straight line, so this is probably going to be an exponential model. How do you find the equation to it, though? Well, your calculator can do it for you. I've already shown you how to calculate the linear models, so I'm going to show you that again, and then also on top of that, how to do the exponential model. So let's go over to our calculators and clear out our lists, and then type this data right here into our calculators. I'm going to do list 1 as our x values and list 2 as our y values, the number of bacteria. So over here at lists, I'm going to go up here, hit clear and enter. Go over to list 2, clear, enter. That clears my lists. And now I'm going to type in all my x values. 1, 2, 3, 4, 5, 6, 7, and 8. And then my y values that correspond to that. That's going to be 1, 1100, 2, 700, 3, 490. Alright, so there are all of our points. First thing I'm going to do is I'm going to do the linear model. We're going to start with the linear. And that's just like you guys have already done. You can actually probably do this all by yourself and then skip ahead to the exponentials. So that's going to be second. List. to go into Calc. And then we're going to go down to linear regression. And we can just hit enter. We don't have to store it into our calculator if we don't want to. Got y equals ax plus b, where a is negative 137.02 x, and then the b, or the y-intercept, is going to be plus 1002.8. Rounded to the nearest hundredth would be 86. The correlation coefficient is negative 0.93. I'm going to round to the nearest hundredth as well, 0.93. It is decreasing, so it makes sense that we do have a negative correlation. Now, how do we do an exponential linear regression? Well, not linear regression, but exponential regression. Well, basically the same way. And you've probably actually already seen it on your menu. So go back to second list, or go into stats, go over to calc, and instead of choosing option 5 where it says linreg, go down to option 7. It says exp reg. That's exponential regression. Hit enter, and here it says y equals a times b to the power of x. That should look familiar as an exponential function. So it says that if you guys remember back, let me just kind of take a side note here. And we said that a while back that f of x equals the initial amount times the common ratio to the power of x. So basically what it's saying is it's telling our initial amount and our common ratio here. So our equation would then be 1673, so 1673 point, let's just go 57. Our common ratio then would be the b here, not r, don't get that confused with common ratio, but b is 0.65. No, we're going to go 0.66 because that rounds up the nearest hundredth, right? That 7 tells that 5 to round up to a 6. And then the correlation coefficient is negative 0.99857. Anyway, if I were to round any of these numbers up to the hundredths, the thousandths, and so on and so forth, basically this would be, and I'm going to write approximately be negative 1. This is really, really close to a perfect negative correlation. So which model is better suited for this problem, the linear or the exponential? All we have to do is take a look at which correlation is stronger. Clearly, the exponential model is stronger. So an exponential regression, or exponential trend line, or linear instead of linear, is actually our best bet here. So if you were going to give me an equation to represent this line and use it for a prediction, you should probably use this exponential equation here. I'm going to do one more example here. This is a little bit more practice. So if you feel like you got it, move on to your worksheet. If you need the extra practice, watch the rest of this video. Here I have a different type of bacteria. It looks like this bacteria is growing. It also looks more like an exponential model, but I'm going to compare the two, the linear and the exponential models, just to show you that exponential is probably the best case to use here. First thing to do, got to go to my lists, clear them out, and type in our data. So 1, 2, 3, 4, 5, 6, 7, 8. And then 1, 175, and so on and so forth. Double check your data, make sure it looks good. I think we're doing all right here. Yep, looks good. And now let's go and do the linear regression first. So second, stats. Go over to calc and do option 5 for linear regression. Hit enter, then enter again. That correlation is positive 0.9, we're just going to go 97, and the equation would have been 139.58 x plus, or in this case minus, plus a negative 72.5, so plus a negative or just minus here, And then the correlation coefficient is 0.97. That's pretty strong. That's a really strong relationship. But let's go check out the exponential regression now. I'll clear my screen, go second, and then stats again, over to calc. And instead of option 5, choose option 7 for exponential regression. Hit enter. This one takes a little bit longer. That equation would have been 135.83 times 1.31 to the power of x, and that correlation coefficient is 0.999, or basically this is going to be approximately 1, which is approximately perfect positive. So this one is also very obvious that the exponential fit is more accurate fit. We can also tell that from our graph here, that it would be exponential. So let's move on to the mastery problem, guys. The mastery problem is not too much difficult than what you've already done. It's just basically everything being combined together and then a little bit of reverse engineering. So first thing you'll need to do is sketch your scatter plot from your data. And so I'm going to do that really quickly, and then but fast forward it. So starting off, all these data points, we have our tenths. Let's see, our tent weight is our x values here. And then we have our cost of the tent, which is here on our y-axis. So let's go ahead and plot those points. I'll do the first two, and then I'm going to speed it up. So 54, 315. So 54 is about halfway between 50 and 60. And then I'm going to go up to the cost of 315, which is going to be, I don't know, somewhere about right there. So that deals with that one right there. 57, 295. It's about right there. And 60, 280. 280 would be about here as well. So, and then we're just going to continue on, and I'm going to speed it up at this point. So there's our sketch. Not too bad. I could definitely have done better. Believe me, I know. No need to make fun of me. All right, next question is, it says, actually a statement, we'll add the regression line to the graph, so let's sketch that in really quick. Something about like that would be fine. What is its equation? Well, that's where the calculator is going to come into play, so let's go ahead and clear my lists out. I'm going to get my data entered in, and really quick, so here goes fast mode. On to the y values. Alright, double check your data, make sure everything lines up. And it does. Alright, then we got to go do, we wanted the equation, so we have to go second, stats, over to calc, and do the linear regression. It looks like it's linear, so I'm going to go with linear regression instead of exponential. And I'm going to round to the nearest hundredth, so y equals negative 8.196, so actually just 0.82 x, and then plus b would be plus 758.76, so 77 is good enough, close enough for me. The correlation coefficient is r, so r equals negative 0.99 if I'm going to round to the nearest hundredths. It's a very, very strong negative correlation coefficient. And then it says complete the table below by interpolating or extrapolating. So that's where my equation is actually going to come into play. So let's clear off my screen over here. Get negative negative 8.2 x, and the x is going to be 50 on this first one. So let's type in 50. Plus the 758.77. So when the tent weight is about 50 and 50 ounces, the cost of the tent is probably going to be around $348.77. We can replace that with 70, so when it's 70 ounces, it's going to be about $184.77. I'm going to skip this next one and go on to these two over here. So when it's $80, sorry, when it weighs 80 ounces, my bad, it's going to probably be about $102.77. And then lastly, when it's 90 ounces, it's going to be about $20.77. Not that anyone would be selling tents for that much, but you know. All right, the other way, we have to actually work backwards. When the cost of the tent is $325, about how much does the tent weigh? These can be approximated from the graph, fairly easy. So at $325, that's going to be about halfway point right here. And then follow that straight down. That's going to be also about 50-ish. So maybe a little bit low, maybe a little bit less than that. So about 50. And I know these two are the same, but we're just approximating here. And then what about when the tent is worth $50? Well, $50 here. Well, then we're between about 85 for the weight. Between 80 and 90, though. So that's how we do it. That's how a level 4 or a mastery level problem is going to work. This tells me that you know all the ins and outs of scatter plots and how to use them and read them. If you have any questions, though, make sure you ask. As always make sure you ask. And thank you for your time.